Today we will discuss refraction through spherical surfaces. So in under this topic we will get 6 cases, generally 5 cases. The sixth case is not much important. So the first case is refraction from rarer to denser medium for convex spherical surface. Real image, because in this case we are going to get real image. Now let us first see how the figure is drawn. So what type of surface is that? It is a convex spherical surface. Okay. So this surface, this one, this is a convex surface, and this is a completely different medium with a convex surface. Now what is the shape of the surface? That one we will determine by observing from the rarer medium. This is a medium, this part is a medium. What is the refractive index of it? It is mu2, it is the denser medium. And this is another medium, refractive index mu1, it is a rarer medium. So if you just look at this surface from rarer medium, the shape looks like a convex surface. Okay, so that is why we have written convex. Now where is the object and where is the image? This O is the object. From object, light ray is going like this, it is falling at point A. Then since it is a curved surface, this one, where is the center of curvature of it? We know that if it completes a circle, then the center of this particular circle is the center of curvature. So suppose here, this sphere, it is making this kind of circle, okay, and this surface is making this kind of circle. This is the center C. So from this center, when we draw this line on the surface of it, then this dotted line, then this dotted line is the normal actually. So remember that normal on any point on the surface is always drawn from the center of curvature. So from C, this dotted line is the normal. Now this light ray, this is the incident ray. So if this is the incident ray, the dotted line is the normal, this I is the angle of incidence. Now we know that since the light ray is moving from rarer to denser medium, it will move towards the normal. So that is why the light ray, it should go this way, it should have gone in this direction, but since this is the normal, it will bend towards the normal, and that is why this is the final light ray, or we call it refracted ray. This refracted ray, in which point this refracted ray is intersecting this line, this is the principal axis. If some light from this object O moves along the principal axis without any refraction, it will pass through. So suppose towards principal axis we have another light ray. So this light ray and this light ray, they are meeting at which point? They are meeting at point I. So the image will be formed at I. Okay, object, image. Now angle of incidence we got I. What is the angle of refraction? Refracted ray and the normal. This is the refracted ray, this dotted line is the normal. So the angle of refraction is this one. This R is the angle of refraction. Okay, first let us see the diagram. Okay, then this is angle alpha. Remember always that with object, the angle made by the incident light is always alpha. With image, the angle made is always, will give it by beta. With C, or with center of curvature, the angle made is always gamma. So this is point P, that is the pole, and then from point A we have dropped one normal till point M. Okay, now this M and P, both the points are very close to one another. So in according to our requirement, in the derivation we will replace M by P, because they are very close to one another. Now object distance is always given by U. So from pole to O, this is the object distance. Image distance from pole to this I is the image distance, that is V. Radius of curvature from pole to this C, this much is the radius of curvature. Okay, so these are the things that we got from the figure. And as I told you that we will discuss here about 5 cases. So in all these 5 cases, the main point is the diagram. If you can draw the diagram, the derivation will be of same type. Okay, so let us now start the derivation. Okay, So here we will apply Snell's law first. So applying Snell's law we get this one. How we get this one? Because we have Snell's law in this way, sin I by sin r, that is equal to what? Mu 2 1. The meaning of mu 2 1 is actually mu 2 by mu 1. So if you do cross multiplication, then this mu 1 will get multiplied with what? Sin I. Mu 2 will get multiplied with what? Sin r. So can we say mu 1 sin I is equal to mu 2 sin r? That's what we have written here. So it actually came from Snell's law. Okay. Now for small angles, sin I is nearly equal to I, sin r is nearly equal to r, so we are just replacing sin I and sin r with I and r. This is given equation number 1. Next, from triangle OAC, remember the name of this triangle because in all the derivations we are using the same triangle, OAC. So same triangle means the name of the triangle will be always same, OAC. So in this triangle OAC, which one is the exterior angle? If you see in the diagram nicely, this I is the exterior angle for this triangle, and the other two interior angle is alpha and gamma. We have one geometrical for this one theory that exterior angle, that is I in this case, will be equal to summation of this further uh, interior angle. So interior angle is which one? Other two interior angle means except this. So other two interior angle means which one? Alpha and gamma. So we'll write I is equal to this one, alpha plus gamma, equation number 2. Then next triangle IAC. In the other derivation also we are using this two triangle only, OAC, IAC. Name will be same. So for IAC, IAC. Okay. For this triangle, which one is the exterior angle? Gamma is the exterior angle. Interior angles are beta and r. So gamma is equal to beta and r, or from this r is equal to gamma minus beta, because we actually need the equation for I and for r, so that these two things we can substitute in equation number 1. Okay, so substituting the value of I and r from equation 2 and 3 to equation 1, we get, in place of mu 1 we'll keep mu 1, I means alpha plus gamma, this one, mu 2 will remain as it is, r means what? Gamma minus beta. So this is done. Next, for small angles again we can write alpha is equal to 10 alpha, gamma equals to 10 gamma. Gamma here also, gamma is 10 gamma minus 10 beta. Beta means 10 beta. For small angles again we can write in this way. So under bracket I have written for small angles 10 theta is nearly equal to theta. Next, 10 alpha will get, if we consider this triangle AOM, that is a right angle triangle, 10 alpha is the ratio of perpendicular and base. Perpendicular is AM, base is OP. So here we are writing, sorry, OM, perpendicular is AM, base is OM. So here I am writing AM by OM. Similarly 10 gamma. So 10 gamma we are going to get from which triangle? ACP. ACP, not P, sorry, M. ACM. So 10 gamma will be perpendicular. Perpendicular is AM by and base is MC. This one. Then this side, mu 2. 10 gamma, again same value, AM by MC minus 10 beta. For beta we are considering AIM triangle. So in AIM triangle 10 beta means perpendicular means AM, base is MI. This one. Now you see AM, this all this AM will get cancelled. So what will have? Mu 1, 1 by OM, 1 by plus 1 by MC, mu 2, 1 by MC minus 1 by MI. Now, just now at the very beginning of this derivation I told you that M and P are very close to each other. So M can be replaced by P, and why we are doing so? Because see, the distances like object distance, image distance, these things always we measure from P. So that is why M is replaced by P in the above equation. So this will be what? OP then, OP. CM will be CP. CM will be again CP. MI will be PI. Now from the figure, OP means OP, this is U, object distance. But remember all the distances, if you consider it like this, this side means towards left side, all the distances will be, this is the origin suppose, towards left, u is towards left, so towards left all the distances will be taken as negative, towards right all the distances will be taken as positive, so u will be minus u. Then r, radius of curvature, for cp we can write it, so for cp r is towards right, so this r will be plus r. Then here also same, 1 by r, then minus pi. Pi means it is image distance, and image distance in the figure it is v, and this is towards right, so this will be plus v only. Okay, next step. So next is, okay, minus mu 1 by u, then this one just rearranging we get it, and then terms including r, capital R, we are taking it in one side, and the rest term we are keeping in other side, like this. Okay, this is simplification, nothing else. Then after rearranging we generally get this equation. So this is the important equation. You remember that mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. So this is the equation that we got, which relates refractive indices with object distance, image distance, and radius of curvature. Okay, in the same way we will do the second case also. If you remember, in the last case we discussed about real image, because that was a real image. You can see this one, real image, because here this refracted ray and this ray means the ray which is towards the principal axis. Here you can put one small arrow. Okay, so this refracted ray and this refracted ray, they are actually meeting at point I, so that is why it is a real image. But virtual image means two light rays, they don't meet but they appear to meet, so that is the virtual image. And everything is same in the next derivation. This is rarer to denser medium only, so convex surface only, but here it is virtual image. And in what condition we are going to get the virtual image? This object, when this object is kept very near to the pole. Here this object we kept it here, no? So if you just bring it close to P, suppose this object, this time I am keeping it here, then the image formed will be the virtual image. And how we are getting that, let's see. First let us see the diagram. Okay, so just like the previous one, here the object is kept, it is near to the pole. From object light ray is going like this. Okay, then what we have the this one normal. From C point always we draw the normal, so this dotted line is the normal. Okay, then incident ray is this one, the solid line. So what will be the angle of incidence? This is the angle of incidence, I. Then as it is going from rarer to denser medium, rarer medium refractive index mu1, denser medium refractive index mu2, so it will go towards the normal, so it will bend little bit towards the normal. So actually it should go like this, but instead of going that, it is bending towards this side, this one, refracted one. Okay, now see this refracted light and the refracted light which is towards the principal axis, they will never meet in this side because they are diverging. But this line, if you extend it backward, then it is meeting at point I. So this is, that means they are not actually meeting, but they are extended, they are extrapolated to meet. So this is the virtual image. So where the virtual image is formed? At I. Where is the object? At O. Center of curvature at C. So in towards the principal axis also, here you can put one small arrow sign, because towards principal axis also we have one light ray like this. Okay, then other things are just like the previous diagram. We are dropping one normal from point A to M, and as we know P and M are very close to one another, so in one step we will replace P by M, sorry, M by P. This is object distance, image distance, radius of curvature. Process of derivation is same. Once you draw the diagram, the process is same. We started with what? We started with Snell's law. So here also we are starting with Snell's law. This is Snell's law. Next step, what we wrote? Sin I is nearly equal to I, sin R is nearly equal to R, as they are small angles. So then we got this equation just like the previous one. Put here equation number 1. Next step, two triangles we considered. One, I told you that the name will be same, OAC and IAC. Now you see in this figure which one is OAC? OAC. So in OAC, which one is the exterior angle? I is the exterior angle. interior angles are alpha plus gamma, so we'll write I equals to alpha plus gamma. Then another triangle IAC. IAC is which one? IAC. Here the exterior angle is R, interior angles are gamma and beta, so R is equal to gamma plus beta, this one. Then these two things we are going to substitute in equation 1, so we got the equation 1 in this way. Then what do? Alpha, beta, gamma, these are very small angles, so we can replace alpha by 10 alpha, gamma by 10 gamma, beta by 10 beta. In this way we replace, okay, under bracket here I have written this one. For small angles, tan theta is nearly equal to theta. Then next step, what is that? Tan alpha, tan beta and tan gamma, that we are going to replace from the figure, right? From the figure we are going to substitute some values. So tan alpha, from which triangle we'll get that? Tan alpha means AOM. In AOM triangle, tan alpha means perpendicular by base, so perpendicular is AM, base is OM. AM by OM. Tan gamma, for gamma which triangle? Which right angle triangle? ACM. So ACM, tan gamma will be what? AM by MC, like this. So here also same, okay. Tan beta means which triangle we are considering? AIM. So in this way we substitute the values just like the previous one. Then what we do? We replace P and M, they are very close, so that is why wherever we had M we are going to replace it by P. So we got like this, okay. Next step, we substitute. OP means what? Object distance. Object distance is towards left, so this is minus U. This is refractive index R, this is towards right, so plus. Image distance, see here this time the image is this side towards left, so image distance V will be minus, but in previous case it was plus. So minus V, then R. And then what else? The terms containing capital R, we are keeping it one side, and rest term we are keeping other side. So if you arrange it, rearranging, we get the same equation. The equation that we got in the previous case, here also we got the same equation, okay. So what is the difference between these two cases? In first case we got real image, in second case we got virtual image. The third case that we will discuss, for third case this will be like this: refraction from rarer to denser medium, but for concave spherical surface. And the shape of the surface, that one we will understand when we look at the surface from the rarer medium. So for the next case it will be concave spherical surface, and remember that concave spherical surface, what type of image does it form? It always form virtual image. But in convex spherical surface we got real image as well as virtual image, but in concave we get only virtual image, only one case. So for that case I will just give you the diagram, okay. Diagram I will give you. The derivation is same type, so you will do the derivation and same expression you are going to get, okay. So the diagram I will give you. So for today, thank you.